Thank you. Hi, everyone. Thanks, Des. Okie doke. So I'll start by telling you a little bit about me, very briefly. I'm an associate principal at Grimshaw Architects. I've got a specific interest in sustainability, biomimicry, and also innovative solutions that kind of like use computational process and technology, I'd pitch it that way, towards unique, hopefully one day regenerative design solutions. I'm a lecturer at the Architectural Association, a tutor at the Environmental and Technical Studies at the AA in London. And this is also why I believe that the collaboration between the academia and the practice is key aspect to what we do. So that's also part of what we're here. A bit of our organisation. So Grimshaw Architects was founded by Sir Nicholas Grimshaw in 1980. We've got studios across all of those locations in the world. We are in London about 260 people, but overall more than 700, I'd say, more or less. We've got presence in a range of sectors, but the important thing of all is that in everything we do, we make sure that we explore the social, the cultural, and the environmental context of each situation so that we can develop appropriate formal solutions for clients and users. So our approach to design focuses on delivering world-class projects that are innovative and make the most of the technology available to achieve projects that are highly efficient and highly sustainable as well. So with the current sort of climate and biodiversity emergency, this of course has never been more relevant. And of course delivering lasting, meaningful designs that bring value to joy, and joy to clients, our users. It's something that we really value when it comes to design, and the connection of people to each other and to the world around us. It's key as well. So finding beauty through ingenuity is part of what we do, our DNA. So our buildings are developed by practical responses to their surroundings. And within this context, considerations around sustainability and climate are a key part of our design processes. And this is nothing it's not very new. This is something that Nick was talking about even back in the olden days when he founded the practice. So this is a really great example I usually like showing, which is the Expo Sevilla in Spain. It's the UK pavilion, and it's a great example because you can see how in 1992 he was already looking into being at the forefront of sustainability, and in this case it was designed specific to accumulate the high temperatures that Sevilla could have during the expo, so people could find some kind of a nice place, a fresh place to be using water and other sort of features to sort of beat the sun and the heat of that time of the year in the city. We've got great commitment to sustainability, so we lead in the industry with these ambitious sustainability targets. They basically are very forward-thinking, and we basically believe that a better future sort of will come if we are able to tackle them. Now, nobody says it's going to be easy, but this is what we're basically trying to do. We're net zero in operations since 2020. We're aiming to be net zero by 2025 with the carbon-ready designs, and social and environmentally regenerative by 2030. And that's big words. But overall our objective is essentially to establish that designs that deliver the outcomes and improves the planet health, restore climate stability and enhance the people quality of life. And at the moment, I'm taking sort of good part in giving this a push in our Grimshaw global practices because, coming from degenerative inputs, going to net zero, but then being even more ambitious and try to go regenerative, which is giving better health to the planet that one you found on your site, is something that we find really, really important. So I've been trying to push that regenerative design framework in the office, trying to understand how are we going to do this, and it's going to be hard, but hopefully we'll get somewhere there by 2030. we are passionate about what we do, and this, and we love taking this seriously. So last year in July, we launched Minoro, which is a platform that it's open to everyone, and it helps architects to achieve lower carbon projects, guiding them through every single stage of design. So Des is going to talk a little bit more about that, but we do that sort of commitment externally with the community and the people around us, but also, we have a suite of documents in-house that are essentially available to everyone in our offices that give basically guidance to our teams and best practice of sustainability, like you can see there in regenerative design in, with sort of an integrated, creative, amount of designers, sustainability leads, technology leads that think and collaborate towards holistic design solutions, which is essentially what we aim for. Next. There we go. So then the question came when there's come to us first time, so, how AI really is going to support us on this journey. And like you all know, and you saw in the presentations earlier, like sometime back, probably 2022, end of 2022, we were just talking with the guys during lunchtime, we started looking at opportunities of using AI to enhance our design processes. So we started with the classic sort of imagery using, Midjourney and other AI sources that were available by then, but actually wanted to take it a bit further and using AI in a more, I wouldn't call it intelligent, but more technical way to feed more into the design process, the day-to-day design process that we were going to do. And so this is why the AiLab somehow is born and as a vehicle to recognize that cross-disciplinary demands and the opportunities of artificial intelligence and produce impactful research communities and the construction sector. This is words from Des when he put the whole brief together. So when Des invited us to be part of this collaborative effort, of course it was a kind of a no-brainer. So how did we do this? We had this team, this amazing team of people, computational design experts. Andy and I came up from the architectural sort of in-project background, and then Pete, who's our sustainability lead. We met with Des and his team for about 6 months on either bi-weekly or weekly basis according to what we needed to do, and started this really, really good fun brainstorming on sort of potential topics that we thought AI could help us to reduce the carbon as part of our design processes. And some of the examples I'll show you in a minute, but in a way we started it by doing a long list, because you could go on forever, and these conversations we started to find at the beginning that were very interesting, but they were super long, and how are we going to get this moving? We only have 6 months until today. So we started by setting up a methodology, let's say, and so we long listed potential research outcomes, which could be, there were circa 10, if I'm not wrong, 8, 10. And then we set up an evaluation criteria in which we evaluated each of them, and so once that assessment was done, then we shortlisted outcomes, and those 4 outcomes that Des is going to present this afternoon are the ones that we decided to dive deeper into it. So some of the examples I was talking about, this is one. So in having conversations about, well, why couldn't we have some kind of machine learning to promote low carbon design via optimized form finding and alternate material specifications. So, this could actually help us optimizing current shell forms and material use, for instance. This is a project that you might be familiar with, this Eden project Morecambe across the roads, and it's a project we've been working for a long while, and hopefully we're going to see it built in the next 4 or 5 years, and that could sort of this machine learning, we started to talk about how these designs could actually be much more efficient by using AI, you see. And so that was one of the topics that we put sort of at a brainstorming with Des and the team. Another one could be around material efficiency. So there's projects like this one, for instance, GridServe, that rely a lot on analytics and data. So think how AI could sort of help us on that was also something that, we put in front of the team and said, well, something like this that actually has something to do with the choice of material, something that trains and like embodied carbon data, or how to define actually even carbon targets. Like it would be something really important. Benchmarks were also super important to us. Then outputs of reliable planning regulation and advice via ChatGPT was another topic that we put there for discussion. So, the idea of developing an existing AI tool that could go even further and help us deliver in projects like master plans, because we work across different scales. So, like from master plans to smaller projects, you always, need some planning regulation. So having that advice in real time and from a sort of machine learning system that, would be kind of great. Then another one, had to do with that development of a more effective sort of operation and maintenance manuals for post-occupancy pre-building. So essentially, we do have our projects, but we not necessarily have enough good information of the post-occupancy and what happens after, the building's been in use for years. So, like a machine learning training that, works with the operational side of the building, but also what happened with its use and the public that goes and visits them. In this case, like Eden Project in Cornwall, sounded like a really good one to explore, like the potential to improve the handover of the knowledge from design teams to the owner essentially and the occupier as well. So, and how do the carbon life of the operational building, but also through the efficient operation in a day-to-day basis could actually help, the targets, let's say. Another one had to do with, like scenario of planning for weather performance, and Morecambe again is a really good example of this because, we could design a project across the road on this site over there. I don't know if you see my cursor, you don't, but, you can see the image. And there is a big risk of, flooding. What's going to happen in 80 years with this site? So essentially, having an AI tool that actually helps us to predict, in its best possible way, cross-breeding information will be really interesting as well. So those are some of the examples. Then what we did was to evaluate, the initial outcomes. It was 7. Mainly the ones we came up with. And then we shortlisted according, I don't know if you can read there, but, there was some of the criteria assessments that we applied. In that, of course, the time that we had to develop the whole thing was a variable, so, a parameter to analyze. And from there, we basically shortlisted 4, which Des is going to explain in a bit more detail now. These are the 4 ones. So the first outcome was the large language model integration of the UK zero carbon standard at a building concept design stage. The second one had to do with the local knowledge workflow integration at the building concept stage to augment low carbon design decisions making. Third one's to do with a machine learning based method for the generation of 3D forms in Grasshopper using a parsed image database of seashells. And the fourth one is the integration of the ML based on structural shell evaluation maps into the building concept design stage. I'm not going to say anything about them because Des is going to talk about them in a lot more detail. But all I want to tell you is that, then all of these sticky notes were a little bit part of, trying to illustrate this really, really fun journey that we had over the last 6 months. Talking about, giving feedback to, from a technical sort of perspective, academia as a point of view, and then us coming from a more, practical sort of, practice side of things. It was just super interesting, at least for us to sort of go through. And then, one of the important things is that in the end, all what this prompted was this amazing sort of holistic collaboration around trying to understand how we design things and how a design process is processed by humans, and then how that sort of works when you basically have a computer that needs to do it all, and then how is that crossing happening? That's something that we really found interesting, and that Des is going to explain in more detail now. So I'll pass over to Des now. Thank you so much.
Okay, thank you, Camila. That was an excellent summary, really, of what we've been doing for about 6 to 8 months. This is the kind of university side in terms of the people who are involved in it. It includes engineers, it includes software architects as well. And obviously Grimshaw's were incredibly essential to it. And as Camila said, effectively what we're looking at specifically is to look at how processes of AI target reduction of carbon expenditure. And the exhibition that you see behind you is some of the outcomes of that work, and particularly a summary of the work that's happened. And as has been discussed before, there are 4 outcomes that I'm going to go into. So it's worth noting that the method in which we collaborated and met was through this little thing called Miro, if you've ever heard of it before, but it's an excellent kind of collaboration software, and particularly with something that was quite kind of early stages in terms of methodology and understanding. It really helped free up the process of stating a problem or a solution and then getting direct feedback. You saw that in terms of things like post-it notes and ways in which we could all collaborate effectively at one time. And a really important part of that was for us to try to understand the process of how we design fundamentally, how that will change in relation to machine learning. So one of the great things that we got Grimshaw's to kind of come up with is to really piece apart how they design fundamentally with computers currently. How is the human and computer process working? And what they came up with pretty instinctually is kind of almost a circular, iterative, but also flowing human approach from sight at the top through to consideration of constraints through to form, and the design process is almost a ribbon of narrative that flows through all those things. And then we also got them, to imagine a fully automated machine learning based approach and how that might fundamentally differ from a human in the loop approach. So what we then did is kind of say, okay, well, we've got this human approach, which is human plus computer, and we've got this entirely automated machine learning based approach. What we're kind of proposing is a combination of the two, and the AiLab was fundamentally looking at the design processes that occurred with that. So here you see on the right-hand side effectively a summary of where we kind of think the process of design actually evolved through our discussion and our communication. And as the 7 long list that Camila was talking about before, we then reduced it down to the 4 outcomes here. The first of which is bio-inspired optimized geometry. So here, this came really fundamentally from Eden's interest, and I suppose Camila's interest as well, in biomimicry and how natural forms kind of inspire architecture. And obviously, natural forms are an incredible kind of resource for architecture because biology has evolved over millions, billions of years to come up with optimized, idealized structures through effectively through modification and incremental change. So what we kind of thought is, well, how do we begin to look at nature? How do we begin to look at natural structures and processes? And it's fairly easy now to, I think you saw it in some of the examples before, but to take an image and through photogrammetry effectively create a scan within a computer to then begin to play around with it. But what that then doesn't necessarily do easily is make it easily geometrically editable, and it doesn't necessarily have the qualities of the original. So we kind of thought what would be a fantastic idea is to take the analogy of the seashell and bring it to its natural kind of conclusion in terms of what if we were to literally take a seashell and scale it to a building and start to look at it in terms of its structural efficiencies and the way in which it works in the design process. So how we went about this is we built a machine learning model that was trained on kind of thousands of millions of data images of existing shells, but also millions of iterations of synthetic data that we generated ourselves. And we then got the shells to effectively, we then got the shells effectively to, or the computer to effectively parse data from images. So the machine learning process took the photos of the shells and began to dimension those shells, so to begin to understand what lengths are, what depths are, what widths are, and compare these to the data set of real shells. And then in Grasshopper, which is a kind of parametric modeling software, we were then able to create mathematical geometries which are describably generating into shell forms. So effectively on the top here you see kind of a common whelk, and below you see a sea snail. But these are full geometries that if you input dimensions into them, they can actually begin to generate those shell shapes themselves. And the concept is that we then use machine learning, which is built on this huge synthetic data set of varied variations of these shells, to then be able to parse or measure images of those shells, to then input that into software to then create a fully digital version of that shell. So in summary, here on the left, you see a photo we took of shells. So you'll see some of them at the back. But from those images, the machine learning model would then begin to measure and identify the dimensions of them, the features of them, input that into the Grasshopper definition, and then come out with an actual geometric form which is entirely editable. And the reason why this is kind of quite useful is because it remains editable, then you can then also begin to look at the performance of it, and the performance particularly in terms of structural analysis from that past information, but also material analysis as well. So it's literally almost taking the metaphor of seeing shell shapes and imagining them as buildings, which, I suppose a completely honest way is some of the approach in terms of biomimicry, and obviously, we see across the road as well, a strong influence from shell structures as well. So this was really pushing that to its extent, and the way in which machine learning does that is by allowing anybody to pick up a shell off a beach, take a photo of it, and then have a directly editable and performance checked version of that structural typology to be able to make an early design ideation kind of idea or thought in relation to how effective it is or how carbon kind of efficient it is. The second outcome was where we're looking really at site strategies for low carbon building. So we looked at, for example, transportation patterns. So we were looking at particularly at traffic and existing traffic patterns, modeled from traffic data, things like local bus information as well. And that was really to look at reducing impacts of predictive and live traffic congestion. And what that can do is obviously if you've got delivery to site on a particular day, at a particular time, what you might want to do is think, okay, is there congestion at that time? What will the site's delivery be like on Tuesday in 2027? So to really try to reduce the impact of carbon in terms of fuel economy and delays to site. The other thing that we looked at in relation to this was also kind of conversational AI, where we effectively put ChatGPT into Grasshopper or injected it into Grasshopper and began to conversationally ask it questions about how can this building be more solar optimized, or how can the transportation efficiency of the routing and the location of things like doors and access be optimized. The other quite interesting thing, and again this was an entirely exploratory process, very few people have kind of been through this and published early on, But we also went through a kind of version of really looking at the way in which large language models can facilitate synthetic debate. And what we mean by that, I suppose, is looking at the ways in which, for example, if you go out to planning, and as you know, the public have very different views on buildings and the approaches to them. But how might a large language model begin to mediate between two very opposing points of view? And in order to do that, I set up a very simple problem, which is a square. And as you can see at the top right, and again, using a JSON, which is a kind of a way of transferring knowledge from ChatGPT to Grasshopper, we asked the large language model to imagine a New York block, and then to imagine a Paris block. Now, we gave it the parameters of density, we gave it the parameters of building height, we gave it the geolocation of New York, we gave it the geolocation of Paris, and it is able to understand things like density, it's able to understand things like building heights, interrelationships between courtyards, also pavement widths and road widths as well. One of the interesting things you can do with this as well is that you can also get it to take on the personas of individuals. So here we did quite a creative thing where we asked it to take on the persona of Jane Jacobs on one side, who is a pro-sustainability advocate, and then Randall O'Toole on the other. And we asked them to comment or to basically try to combine and to try to appease both parties in the analysis of the New York image. And on the right-hand side, you see some of the output from that to begin to start, where it begins to start saying, well, these are the differences, but we think these might be the ways to bring these two views together. So it could be a really interesting response to mass planning applications and the way in which we navigate those issues about sustainability. The third was looking at large language models and the zero carbon standard, and I suppose this one is about retrieval augmented generative based large language model interfaces. So effectively getting or training a closed large language model to look really, really carefully at the zero carbon standard. And what it could then do is through conversation with the kind of chatbot that we created to begin to actually generate the Excel database for that. So effectively you're just speaking to the net zero carbon standard and then also populating the database. So obviously we're somewhat concerned with the kind of similarities in terms of Clippy or AI Assistant with that. But we think some of these things are important because they also help inform us in terms of some of the background information about the zero carbon standard that we might not all fully understand, some of the really technical things. And then finally, we looked at surrogate models, so particularly in relation to the structural, environmental and sustainable performance of forms. So what we did here is we took the kind of principle of the shell structure and we created millions of synthetic data. So we tested it in millions of different variables, and we looked at ways in which we could, then, through early design ideation, effectively get the large language model to instantly predict and to instantly give feedback on early model shapes. So, for example, if you were to skew the shape significantly, how would that impact the structure of it? How much weight would that add to the material? What would that do to the carbon of it? And here you see all the various, or some very small sample of the synthetic data that I was trained on to populate the surrogate model that would then be able to allow you to instantly choose one, and it would come up with a very quick solution to it without having to go through these mass loads of computation that we'd normally do. So, in summary, what next? Well, we've done a lot of the work. We need to review the outcomes. We need to really kind of sit down and go through it, and we need to publish research on these findings. And I think in order to do that, we will need to test out methods with practices. So if anyone's interested, speak to me after, or I'll get in contact with you, or you get in contact with me. We're really interested in how this will also begin to play out in practices elsewhere. Other than that, I think that's it from us. So do explore the exhibition. The building tours continue now. I think there's perhaps one more or two more to finish. Coach for students who remain is at 3 o'clock from outside the front doors. And I think that's pretty much it from us. So thank you very much for attending. And we will see you, I'll see you probably on Monday, most of you. But if not, thank you very much for attending, and I hope it was useful for you to join in. Thank you. Bye-bye.